Hey everyone, so imagine this. Yesterday we learned how to name a box in Python. Variables, right? Today I looked at that box and thought, okay, fine, I named it. But what is actually inside this box? Is it a number? Is it text? Is it just a full shopping list? Or is it just nothing? Python smiled at me and said, relax, I got different data types for that. So, welcome to the chapter for what's inside the box. Let's open the box together. Let's understand what are data types. Data types tell Python what kind of value is stored inside a variable. Think like this. Numbers are one kind of material, text is another, collections are bags, true or false are switches. Without data types, Python would be confused like should I add this, should I join it, or should I loop it? So data types gives identity and behavior to the data. But how to check a data type? Python gives us a simple magic mirror, it is called type of function. Whenever you put inside it, Python will tell you whether it is an integer, whether it is a string or list or any other data type. So anytime you are confused, just ask Python politely. Let's understand this type of function with an example. Name a variable something called number. Let me give some value. Okay. Now let's check what this variable is holding, which kind of data type it is holding using this type of function. I'm just printing that out. So as I am checking the data type of this variable in the type of function, I have mentioned that variable and I am printing it out. Let's check it. So here if you observe, the output gave as the class int. It is indicating that this variable is holding an integer. Here the 4 is an integer. So using this type of function, we can understand what kind of variable, what kind of data type a variable is holding. Python has a big family tree. Before diving in, let's zoom out and see the big family tree. Python data types are mainly divided into four types. We have primitive or basic data type, then the second one is collection or sequence, the third one is set types, and the fourth one is mapping type. Now let's meet each member of this family one by one. Let's get into the first data type that is integer, which is also called as int. This int stores the whole numbers which has positive, negative and zero value. It don't have any decimals, no drama, just a clean numbers. So in this integers we can store age, count of items, IDs, etc. If you are counting on something, int is your best friend. Let's understand this integer with an example. Okay, now let's understand integers. As I have already mentioned, the integer represents the whole numbers, positive, negative, or the zero value. So let's take some variables and the values and just check the type of that function. Let me take an age variable, give a value 22. Let me take a number as a variable. Then let me give a negative value that is minus 100. Okay, let's now print the number and the type of it. I'm printing age, then type of age to check the data type. Then I am printing the number and the type of number. If I check the output, the 22 here is being identified as an integer and minus 100 is also identified as an integer. So the integer holds the whole numbers, 0, positive numbers and the negative numbers. Here using type of, we have identified the data type. The second data type is float. It is a decimal number. Floats are the number with the decimal point. So it stores the values like money, height, temperature, etc. So anytime you see a dot, Python says, this is definitely going to be a float. So use float when precision matters the most. Let's understand this float data type with an example. A float Let's take an constant value, that is, the value of pi, that is 3.14. It is already giving me 3.14. I'll take it. Then if I print the value and the type of it, it gave me the output as 3.14 as float. So wherever you see point, it is considered as a float. So whenever you want something precision values, you must use float. For example, in temperatures we have 36.2 or 98.4, so that point matters. That in marks, even for scores, like if a student get 98.3 percentage, then that point 3 matters. Then at that time float is very much important, and we can use the float data type. The third most important data type is complex. This is mostly for the math wizards. These complex numbers look fancy. They have one real part and one imaginary part. These are mostly used in engineering, signal processing, advanced math. Let's understand this complex data type with an example. So let's understand the complex data type. So as I have mentioned earlier, this data type has both real and imaginary parts. So considering z as my variable, I will give both the real part and the imaginary part, 3 as the real part and 4g as the imaginary part. If I print this out, let's see what I'll get it. See, you got 3 plus 4g as the output. But if I want to print the real part separately and the imaginary part separately, then check this out. The variable name dot real is for the real part, and print of the variable name and imag imaginary for the imaginary part. If you just execute this code, see, you got this. The real part, you got it as 3.0, the imaginary part as 4.0. If you check the type of this variable, we will be using type of function and z. If you just check the output, it gave the class as complex. The next data type is string. String stores text, anything inside the quotes. It has names, sentences, messages, and even emojis. String can perform different kinds of operations like join together, repeat. If humans can read it, it's probably a string. So let's understand this string data type with an example. Now, next we'll learn about the strings. Okay, string is something that is being enclosed in the double quotes. So for this, I will be giving a variable as name. Let me enclose it in a single quotes. I will give it as Alex as a value. Let's check the type of it. See, the class that it has is a string. So it is naming that this variable name is having the value Alex as a string data type. The most important thing about the string is it performs some operations. It can be concatenated or repeated. So concatenation here is nothing but joining two words or joining two sentences, and repetition is like repeating the word or the letter or a sentence multiple times. Let's understand this with an example. For example, let me print this out. Print of, okay, let me name it. Name is equals to Alex. Alex loves, I'll give the language. Okay, let me write the language as well as Python. See here, if you observe, I gave a two variables that is name and language. I have given a two values, Alex and Python. Here I am printing name plus loves plus language. This plus is something that is used to combine these words or join these words. So if we run this code, I got Alex like loves Python, but something is missing in this, right? That is space. So let me do one thing. I'll give one space here, and after loves, I will give one more space. If I print now, I got the output as Alex loves Python. So this plus operator is will work as a concatenation in strings. Let's just understand the repetition also here. If I want to print this Alex three times, I'll use the repetition operator here. For example, print of the name into price. So in the previous one, the plus was used as concatenation. Here, the asterisk or the into will be used as a repetition. So here the Alex will be multiplied three times. That means it is printed thrice. Let's check the output. Can you see here? Alex, Alex, Alex. The next important data type is Boolean. The booleans are the decision makers of Python. It only has two values, either true or false. Either it is on or off, or it is a yes or no. They usually come from comparison. Think of boolean like a switch, on or off. They are very small yet very powerful. Let's understand this boolean data type with an example. Now let's understand the boolean type. So, as we know, when we hear this data type as a boolean, we get two things, that is true or false. So, these booleans are meant for the truth values, that is true or false. Let's check their types. I will give a variable here as a student. I'll pass the value as true. Is eligible is another variable. I will pass a value as false. Always remember, when you pass these values, the T should be capital T and the false should have a capital F. If I print the type of these variables, let's check the output, what I get. Here, can you see the class is given as a bool. So these are considered as a boolean values. One more most interesting thing about this boolean is they are often results of comparison. They are often used in terms of comparison. For example, print the number 5 is greater than 9. If you print this statement, the output that I get is either true or false. If this condition satisfies, then I'll get true. If not, I get false. Let's check the output. Here it is false because 5 is less than 9, so false is printed. Next we have none type. This one is quite interesting. None means I exist but I have no value. It's not a zero, it's not a empty, it's literally like nothing. These are used when a variable is waiting for a value, a function doesn't return anything. Python politely says nothing to give you right now. So let's understand this none type with an example. Understand the none type with an example. So this none type, as I have said it, it represents the absence of a value. It has nothing, like no value is being entered and it is waiting for the value. For example, let me take a variable as result. Let me pass a value as none. Print the type of it. If I check it, I get the class as none type. This is what none type means. Let's check what this will return. Let me give a variable num as 0, something like category as double quotes. Here 0 means nothing, empty strings means nothing as well. If we print the type of these like num and the type of result and the type of category, let's check the output. See, these three are different data types. Here 0 is an integer, obviously, because 0 as integer defines it takes a 0 value as well. Category here is a string because it has been enclosed in a quotation marks. So none is simply empty, which has no value, but these two are different. The next important data type that we have is a list. It is a flexible bag. So list is kind of collection of item. It can store the numbers, strings, mixed data, and the best part is lists are changeable. These are mutable. You can add things, you can remove items, you can modify items, and you can perform different kinds of operations. So we can consider lists as shopping lists, students lists, scores. Lists are used like everywhere. So let's understand these lists with an example. So as lists are collections that hold multiple items, let me give a variable as fruits. Let me add different fruits as it already gave me suggestions like apple, banana, and mango. Let me print this out. Yeah, I got the output as apple, banana, mango. Okay, now let's check the type of it. Print type of fruits. Let me check what it gives. Yes, it gave us the class as list. Okay, what if I just want to access one particular element from this list? That is also possible. We just need to print fruits of 0. If we just execute it, we got the particular element. So here in the list, the elements has indexes. The index starts with 0, 1, 2, and so on. So here the index of an apple is 0. If I want to access this element, I gave in the fruit the 0th index I want to access. We will learn different kinds of operations that are happening in lists in further classes. This is just for an understanding. You can also append something into the list. Let's check that. For example, I want to add the orange to my fruit basket. What I'll do is I'll just use an append of I want to add orange. That's it. If I print the fruits again, let me just remove these. See, the orange being added to my fruits basket. Okay, let's learn in depth about lists in a further classes. Let's move on to the next data type. The next most important data type is tuple. This tuple is like a list but with some discipline. Once it is created, you cannot change it. These are used when data should stay constant, like coordinates, fixed settings, etc. So when you compare it with a list, lists are something which are flexible, tuples are something that are fixed. Let's understand this tuple with an example. The next one is tuple. Let's understand tuples. Let me take coordinates as a variable. Here the tuples are enclosed in these kind of brackets. Enclosed brackets. In the previous, when we learned about the lists are enclosed in the square brackets like this, and the tuples are enclosed in these closed brackets. So I gave the coordinates. Let me give the values as 10 and 20 inside it. I just want to print the coordinates. Let's just print it out. Yeah, we got the output as 10 and 20. Let's just check the type of these coordinates. Print the type of these coordinates. Yes. So we got the output as tuples. As we have accessed a single element in the list, let's try to access here as well. See, we got the first element, that is 0th index element 10 as an output. The next most important data type is range. Range is a number generator. It creates a sequence of numbers which are mostly used in loops. Instead of writing 1, 2, 3, 4, 5 manually, Python says, relax, I'll generate it for you. It is quite efficient and clean. So let's create a range of numbers. Let's see it with an example.
All right, let's get into the another data type, that is range. Let me take a variable number, let me range it or loop it from 1 to 10 numbers. So always remember, in this range, it always starts with the start number, that is 1, but the end number is exclusive, it is not included. Let's check that. I just want to print off number. Let's check what this gives out. Boom. It didn't give me the numbers like 1, 2, 3, 4 till 9, but it gave something like range of 1 comma 10. Let's fix this out. So if you want the numbers from 1 to 10, let me give it in a list form. Let me print these numbers in a list format. If what I just did, I just converted this range into a list. So if I print it, I got the numbers from 1 to 9. See, as I told, the 10 is excluded from this list. Let's just print the type. See, it got the type as range. Alright.
The next most important data type is set. Set is a unique club. It stores the unordered items. It has only unique values. When you think of duplicates, Python says, in sets, duplicates are not allowed. It is mostly great for removing duplicates, set operations like union, intersection. If in any data, if uniqueness matters, then use set. Let's understand more in detail about set with an example.
Now let's get into the another data type, that is set. Let me take a variable as colors. Let me see, in this set we use these curly braces to enclose the data. In the lists we use the square brackets. In tuples we use these enclosed brackets. For sets we will be using these curly brackets, remember that. Okay, let me give different kinds of values, something like 1, 2, 3, 4, 5, 2, 3, 4, 1, 5, 2, 3, 4, 6, 2. Let me just print this out. Print of colors. What? We gave these many numbers, but only 1, 2, 3, 4, 5, 6. 6 numbers got printed out. Why? This is because set always chooses for uniqueness. Whatever the duplicates are there, it just get rid of it, just removes it. That is the reason we only got 6 numbers inside a set. That is one unique quality about set. Let's check the type of it. See, it gave class set. So this is all about set.
Now let's get into a frozen set. Frozen set is also like a set, but it is locked. Once you created it, you can't add it, you can't remove anything, you can't modify. Use it when data should stay unchanged forever. Let's understand more about this frozen set with an example.
So as we learned about the set, let's understand about the frozen set as well. Frozen set. Let me give the variable as frozen set of. Let me give these values only. Let's just print this out. Let's execute it. See, here when I executed the normal set, I got a values of 1, 2, 3, 4, 5, 6. When I have executed the frozen set, it gave me the output as frozen set of then the values. Let's just print the type of it. See here, this is the type of a set, then this is for the frozen set. But what is the difference between these two? That is, when you want to add something into a set, let's see what happens with an example itself. For example, I want to add something 100 value to a normal set. Let's just do that. Normal underscore set dot add of 100. If I run this, see what happened. The 100 got added to this set. But what if I had that 100 to a frozen set? Frozen, that is a variable name. Dot add is a function. Frozen dot add of 100. Let's just execute it. See, we got an error. It says the frozen object has no attribute add. This is because you cannot add, remove, and modify items in a frozen set. This is because they are fixed and unchangeable once they are created. That is the main difference between the set and a frozen set.
The next data type is dictionary. It is a key value powerhouse. It stores the data in a key value pairs. For example, if you want to store a name in a variable of key name, and the value can be any name like Joey, Princey, etc. It is perfect for profiles, configuration, mini databases. It is very fast and very powerful. Let's understand more about dictionaries with an example.
Okay, so now let's get into the most important topic, that is dictionary. Let's understand what it is with an example. Let me take a variable as a student. This student is also this dictionary is also defined in a curly braces itself. It has a key value pairs. For example, your name that I have took is a key, added its value, something like this, Neha, then the age. If I just execute it, print of student, see, this is what I got, name and age. Let me check the type of it. This is a dictionary.